Hi, Mrs. Ross. I hope you're doing well. Drake and I, for the biology research experience, decided to test whether mice in the presence of incentive can learn complex patterns in the form of mazes, enough to decrease the time it takes them to complete the maze and reach the incentive. The test was done with two groups of 3 mice, Group A and Group B. Group A completed the same maze for every trial run to test if the house mice can learn the maze, and Group B completed a new maze of the same difficulty and length for each trial. The hypothesis was that if mice A completes the same maze for every trial, and mice B completes a different maze for every trial, then mice A will see reduced times until the threshold potential is reached, whereas mice B will see steady time throughout the experiment. Mice were used to test pattern learning in this study because of their genetic, biological, and behavioral characteristics that closely resemble those of humans.
The group's driving question was, can house mice, also known as mus musculuses, adapt to learn and recognize patterns in the form of a maze and reduce their times in order to receive an incentive?
Now onto the variables for the experiment. The independent variable for this research experiment is the presence of an incentive, because if the incentive is taken away, the mice would have no reason to use pattern learning skills to explore the maze. The dependent variable is the amount of time it takes groups A and B to complete their respective mazes. The control variables included the mice living conditions throughout the course of the experiment. All mice lived in the same controlled environment, were fed at the same time, and tested at the same time. The difficulty and size of the mazes Group A and Group B will get were also variables. The type and amount of the incentive used at the end of maze, the time in each of the 3 phases of the experiment, and if the mice are from the same purebred species and the same mother.
The group's hypothesis was, if mice A completes the same maze for every trial, and mice B completes a different maze for every trial, then mice A will see reduced times until their threshold potential is reached, whereas mice B will see steady times throughout the entire experiment. Jackson and I chose this hypothesis because mice have a similar prefrontal cortex as humans do, which is the part of the brain that controls pattern recognition, which is what our whole BioRex project is about.
Now for the background information. House mice were used in an experiment as opposed to other rodents for several reasons. First, they are convenient to acquire, handle, and maintain. Secondly, house mice adapt to new environments very quickly as opposed to other rodents such as hamsters. Lastly, house mice were used in all of the case studies that inspired us to choose this topic. For this experiment, there were 3 phases. Number 1 is the acclimation phase, where each mouse would enter the maze with no interior walls for 7 minutes prior to testing to accustom them to the maze area. Number 2 is the acquisition phase, where each of the 6 mice completed the same maze one time to gather a baseline time for each mouse. Number 3 is the testing phase, where each mouse will complete trials 2 through 12. This phase is where the bulk of the data will come from.
For the group's materials, the materials we needed were first 6 identical house mice, obviously, from the same family, so there's no lurking variables and they have roughly the same genetics. Legos, roughly 300 to 400 small pieces, plus 2 Lego bases to construct the Lego mazes on. Next, we needed some KT Fiesta food for the mice, roughly 1 pound of the grain and seed mixture. Next, we needed a Sharpie to label A and B on the randomly assigned mice. Next, we needed water, roughly 1 gallon, and we may have extra at the end, which is totally fine. Also, we needed a stopwatch for these trials, which conveniently enough, we have an iPhone, so very simple to do that. We also need a shoebox or any other environment, depending on the experiment anyone else is doing, just so all the mice can live in this environment. Again, no lurking variables. And lastly, 1 jar of peanut butter.
Now onto the procedure. Step 1, purchase and label the mice. Step 2, place the mice in their living environment for 2 days to familiarize them with their environment area before testing and running experiments. This will help eliminate variables and increase brain function. Feed each mouse 7 grams of KT Fiesta food each day and provide each mouse with 10% of their body weight in water. On day 1 of trials, each mouse will enter the maze arena with no interior walls for 7 minutes to complete the acclimation phase, where the mice will become comfortable within the arena. After each mouse has its 7 minutes of acclimation, the interior walls will be inserted for the first maze. Each mouse will go through the acquisition phase, where baseline times are gathered for each mouse. On days 2 through 5, the testing phase will begin. Each mouse will complete its maze 11 more times before the experiment is over. During the testing phase, the mice will be fed and tested at the same time each day to eliminate variables. Group A will complete the same maze for all 12 trials, and Group B will complete a new maze for all 12 trials. The reward at the end of the maze will be a tablespoon of peanut butter. Using an iPhone, times will be measured in seconds for how long it takes both Group A and Group B, and then those times will be recorded into an Excel chart. The results for Group A for every mouse and each trial can be shown in Table 1 on the right. Group A was the test group, where each mouse would complete the same maze for each trial. The group average for each trial can be shown on the furthest right column. The results for Group B can be shown on Table 2 on the right. Group B was the control group, where each mouse will complete a new maze of the same difficulty and length for each trial. The group average for each trial can be shown in the furthest right column.
For the group statistics, as you can see in the two groups t-test, the one-tailed p-test was 0.0007 and the two-tailed p-test was 0.00147. This shows that the group's hypothesis was clearly supported. Also, in Chart 2 titled Average Comparison, we can clearly see Group A's average had a significant decline throughout all 12 trials, and Group B's average time merely stayed the same throughout all 12 trials. This is a clear visual representation that proved the group's hypothesis that it was in fact correct, and also that Group A's times did in fact decrease more, way more than Group B's.
And now for the analysis and discussion. The purpose of this experiment is to study and test the pattern learning capability in house mice. The experiment was done using two groups of mice, A and B, with 3 mice per group. Group A will complete the same maze for all 12 trials, and Group B will complete a different maze for all 12 trials. The hypothesis was that if mice A completes the same maze for all 12 trials, and mice B completes a different maze for all 12 trials, the mice A will see a reduced times until the threshold potential is reached, whereas mice B will see steady times throughout the experiment. After completing the testing phase of the experiment, the hypothesis was supported because of the conclusive data. Looking at Chart 1, it is evident that Group A times on average dropped by 50% over the 12 trials, compared to Group B, whose time stayed relatively steady throughout the experiment. The averages for each of the mice groups for each trial were also calculated and can be seen on Chart 3. The group averages data was analyzed using a t-test paired 2 samples for means. The t-test further supported the hypothesis because the pt value for the one tail was less than 0.05.
In conclusion, it is clear from previous data provided that the hypothesis for the group was supported. Group A's difference from initial to final was 45.57 seconds over the span of 12 trials, while Group B's difference from delta initial to delta final was only 9.22 seconds over the span of 12 trials. This clearly shows that mice do in fact have pattern learning skills just like humans. We would also, before we're finished with our presentation, like to thank a few people that have helped us out along the way. Those people include Miss Ross, who obviously helped us out this whole year with bio. I know we didn't get to finish the year off, so I have to tell you over computer, thank you so much for everything you did for Jackson and I this year. I wouldn't have been the chemistry or biology student or just a science student in general without you. Thank you so much, Miss Ross. Also, we'd like to thank PetSmart customer support. If we were able to contact them, they helped us try to look for mice. Obviously, we were unsuccessful, but they would have been very helpful, so we're thanking them. And also, Maze Engineers. The group would also like to put in our references really quick, just so everybody knows that we are not plagiarizing and whatnot. Once again, thank you guys so much for tuning in, and we will see you on the flip side.